All right, so we are now live.
All right.
Okay.
And hopefully Allie will be here shortly.
Oh, she is? Okay, good. So what did you guys think of lesson 10?
I didn't get to review much of it just because I've been having issues at work, so I didn't get to see it too much, but how about you?
I think working through the problems has been okay, other than Angie, I've had problems just like you, just, having to put, if I'm asked to put things in my own words, how, in your own words, what would you say, those just things are really hard.
Yeah,
I
that's
guess I
where
need
I ran
to,
into trouble.
yeah, so I'm glad that the tests are multiple choice, so I don't have to do that. But, when they ask, you to put it into your own words, it's like, oh my goodness.
Yeah. Okay, sure. Well, and it's keeping the formulas straight with this one, I think.
Yeah.
Margin of error, you do this way, and then the confidence interval, working those things together. I know how to do them, but I do have to refer back and make sure I'm doing the right one, the right calculation. So,
and making sure you're using the right numbers. You have to be careful that you're pulling the right data.
Yeah, exactly. Because, as soon as you put that in, because if you start with there and then you go all the way through all the problems, and when I was working through the work, I started doing a problem like that. And I had the answer, so I knew that I was doing it wrong. And I couldn't figure out what the problem was. And I went back, and that is where I was making the mistake.
Mm-hmm.
So yeah, that's just, again, with this, it's so easy to pull the wrong thing with, if you're not looking carefully enough, and you run with it and then end up with all the wrong answers.
Yeah, I'm so grateful that she gave us that list of the different, the symbols and stuff like that. So then I'm not confused at what these symbols are, and oh yeah, that's the mean, and that's the standard deviation, and the simple. Yeah, that just made it easier for me.
Those first few, I feel pretty confident on the n and the mean and the standard deviation.
Yeah.
But going forward and adding to them, I was a little worried. So I'm really glad to have that little cheat sheet to make sure I'm doing the right one.
Teresa, where did you find that list of, I can't remember where I saw that.
That was the table of common statistical symbols that she gave us. It was just was it a link, Angie? I can't remember.
Yeah, it was in her little weekly
notes from Sister Wilkinson.
Yeah, it's in there.
I have to check that out because I know I've seen it, I just couldn't remember where.
Yeah,
there's a little link there. You can click on it, it opens up.
Yeah.
Okay. Well, do we want to wait just another minute for Allie before we look at the quiz, or anything else we need to discuss before we go to the quiz, or what?
Yeah, let me check on it real quick.
Okay, and it says we're supposed to review the part 2 of the preparation.
Two.
Yeah, so were there any problems I didn't have any problems really doing the work. Again, the first one where it says, what are the 3 assumptions that need to be checked before you compute a confidence interval for mean? Again, just putting it into words. I mean, I knew it, but it's just...
And I didn't even try to. I just put little bullet lines, and I put random sample has to be taken. We have to know the standard deviation and normally distribute it. That's what I did. So.
Yeah.
But I did on all of the calculations. There was one that I can't remember what I was doing wrong now, because we don't have room to write on these papers. And so I start here, I have to move to a different paper, and I end up throwing part of my work away. And I get very frustrated. But anyway, I felt pretty good about it.
Yeah, and then I guess the important thing is to always remember that you're rounding up.
Yes.
Yeah, and unless they specify not to, but yes.
Right. Yeah, and I thought, like the last one on number 13 on part 2 was 157.352. And so, 3 automatically are like 3, so you don't round up, you just keep it at 157, but you're supposed to round to it's 158. So usually it's any 5 and above, then you round up. If not, then you just leave it the same. But this is different. So that for me, I have to remind myself, okay, you have to round up no matter what that first number is after the decimal.
Yeah.
So I think we're ready.
Okay. I feel ready. All right.
Allie said that she'll join us. Her computer's being really slow, so she'll join as soon as she can.
Okay.
Okay.
All right. So
My computer's being kind of slow too, and it's very frustrating.
yeah. I wonder.
Okay.
So answer 1 and 2 as you think you should.
Sorry, guys. My allergies have been horrible.
Yeah, it's kind of that time of year, isn't it?
Yeah, well, I didn't have problems with my allergies before. It's been about a couple of years. I started to have problems with my allergies, and I just had my allergy test, and I'm severely allergic to almost all the trees, every single grass. And so it's like, okay, now I know why I suffer year-round.
Yeah. Not good.
Hello.
Oh, hey.
Hi.
Good.
We decided to be pain today. Like, oh my God.
I know the feeling. Well, we are just now looking at question number 3, so perfect timing.
All right.
We're supposed to find the margin of error for a 90% confidence interval, and we have a standard deviation of 50, n equals 25.
Mm.
So,
Okay, so of
Wait.
course,
Oh, are you on the quiz already?
yeah.
yes.
Okay.
Did you have questions on any of the preparation work that we were doing? Were you good with it?
Yep,
Okay.
I was good with it.
Good. Yeah, we felt pretty good. So yeah, we just are moving right into the quiz.
All right.
Okay. So, but now of course I haven't looked at this, so I have to orient. Where am I? So.
Can you guys hear me okay? Because my thing seems to be going in and out, and it's hard to hear a little bit. So.
Yeah, I can hear you.
I can hear you.
Oh, okay.
Yeah, I can hear you as well.
Okay, good. Thank you.
Okay, so this one, you're using that n equals the z-score times the sigma over the
The
margin of error squared, right?
No, I think it's the square root of n. We're looking for the margin of error.
Oh, yes.
Find my formulas.
Let's see.
So we take the 1.645 times the standard deviation divided by the square root,
Right, so
right?
So times 50
50,
divided by the square root of 25.
25, yeah.
Well, I can't find that equation or formula on the online textbook. So where
let's see.
It was the one where they took the
So
they
it's the
took the
z-score.
formula for n, Or no, never mind. Never mind. Yeah.
We're looking for the margin of error. So go to the contents part and see where it says margin of error. It's like 3.3,
3. Oh, okay. Let's see.
and it'll probably be in that section.
Okay. Oh, fine.
Yeah. They show several different ways. I mean,
Well, what
So-
they're doing is they break it down and show you how they.
how they're coming to that conclusion. But
So is it the population times mu minus 2? Right?
No, isn't it z squared times the standard deviation over?
see, the thing is, if you look for the margin of error, the actual, what it tells you for that calculation, it says 2 times the standard deviation over the square root of n.
Oh,
But
okay.
we
I see.
are substituting, we're not using 2, we're using the interval, the confidence interval of
Okay.
90%. So we're, instead of 2, we're using the 1.645.
Mhm.
Okay. All right.
So I think that's kind of confusing. I don't know why it's so when it's really whatever that interval is. I guess if you're using a whole and not, I don't know, but anyway. So you guys ended up with 1.645 times 10.
Let's see,
Times 10. I got times 50.
6, 4, 5. Yeah, well, she did everything. She did the 50 divided by the square root of 25,
Oh.
and that's where she got the 10.
Okay. Gotcha.
Okay.
And so that would be the answer then?
So
So
16.45.
then I got 16.45.
So I don't know. That's strange. The margin of error.
Excuse me.
I'm just looking at some other problems to see.
Yeah, that's the formula I have written down for it.
Because that seems like a large number.
Just the deviation is large.
Yeah.
That's true. I wonder if that's.
That's right, though.
You guys feel like that is the formula we were supposed to use, though?
Yes.
Then we'll find out if it's right or wrong when we go to the answers. So 0 in it says round to the nearest 3 decimal, or
Yeah, so I just put 16.450.
okay. Just beside. Okay.
I was
Yeah.
writing
So
my.
we'll find if it's wrong. Then we'll figure out what it may be. Oh, did we lose Teresa? Oh no, there she is. Okay.
Oh, I'm here. Sorry. I'm making sure I write down all my equations up at the top of
Yeah.
my paper.
That's what I'm looking at. I have my paper over here
My
with all my
computer's being
equations.
so slow.
Okay. All right. So
For
number
some reason-
4 is statements is true.
Okay.
Isn't it mu is the point estimator of x bar? Or x, what's that? I have to go back.
X bar is the point
Point
estimator.
estimator of mu, yeah.
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 I knew it was one of those middle ones.
So it's the second one, right?
Hmm.
Yes.
Use the little U one.
Yeah.
I always forget that.
So Tricia, are you
Okay.
there?
She was having trouble hearing us. Trisha, are you hearing?
Oh.
Oh, she stepped away. Now it says she joined the call
Can you
again.
guys hear me?
Yes.
Yeah. Are you there? Did you hear
Sorry.
what we were putting for question 4?
Yeah, yeah, go ahead. Yeah, keep going because I'm having problems with my computer, and so that's why. Good.
Okay. Are we still live and broadcasting?
This is
It
still
shows.
broadcasting, but
Yeah, it shows that we are.
Okay. I've got my screen out of the way. Okay, there we go. Okay. Question 5 then. Gina wants a 5% confidence interval for GMAT scores. She knows the standard deviation is 113, and she collects a simple random sample size of 64 and computes the mean of 526. Good question. Ugh. Okay, so what is the point estimate? That's right.
Isn't that the 60? Is 60? No, the 113.
15, the X bar.
Oh, is it the
Yeah.
X bar?
That's the sample.
Oh, what is the
Yeah.
point
So
estimate?
26.
Oh, yeah, that's right. Point estimate. Oh my gosh.
Okay, everybody good with that? Okay.
I didn't even hear. I'm sorry.
It's 526.
Okay.
It's the X bar number.
Okay. So
And
what
for
is
number
the,
4? Okay,
sorry?
go ahead.
No.
For number 4, I was having problems going in and out. I thought it was the second one, but what?
Yes, that's what we put, the second one.
Okay, I'm sorry. I'm just having issues. So. Go
No,
ahead.
you got it? Okay, and
Yeah.
then for 5, you put 526?
Yes.
Okay, so for number 6, now we have to, what is the margin of error for a 95% confidence interval? So for 95%, we use the 1.96, right?
Mhm. Correct.
Where did you get that number? Okay.
That on the preparation work goes over this, and there are 3 basic numbers that you'll use for this. One is a 90%, and that number then is 1.645. And it's in the preparation work. When you go through that and you read through it in the textbook, that's there.
Yeah.
And for 95 is really the most commonly used. And that
Yeah.
number is 1.960. And those are your Z-scores. And then a 99, 2.576. Now we're looking at 95%, so we want to use the 1.960. And this is the same calculation that we just did up above.
Right.
Right.
Just 27.685. Is that what you got?
I haven't even gotten there yet, sorry. So we're taking... $14.125, and then you're multiplying that by the 1.960.
120.
What? So for number 6, we have 27.685. Everybody feels comfortable with that?
I do.
Okay. What is the lower limit of this confidence interval?
Okay, so that's where you take the X bar minus the Z score times the O over N squared.
That doesn't even sound familiar to me, looking for a lower limit.
Remember when you have to find, it's the higher and the lower limit, you do the X bar plus or minus, plus being the higher limit and minus being the lower limit of your Z score. Do you remember that one?
Yeah.
I don't know what I was doing.
So we're taking the 526
26.
minus
1.96 times 113 over the square root of 64.
So that whole part is squared. Say it again. We're doing 526 minus 196.
The other way to do it, since we already have the margin of error, is just 6 minus the margin.
So
What's that?
27.65. Is that what we're subtracting? Okay, I'm confused now.
526 minus 1.96.
So there's 2 ways to do it. You could do the 526 minus that whole formula again, or since we just calculated the margin of error, you can just do 526 minus the margin of error we did.
Which is the 27.685.
27. Okay, yeah.
For my brain, I had to go through the whole thing over again.
685. Is that what we said?
So, Allie, did you get 498.315?
That's what I got. These numbers all just seem really large. So then for the upper limit, then we're just adding it.
Right, you're doing the same thing, you're just adding it. So 526 plus 1.96 times the margin of error, the 27.685. Just 580.263.
Wait, why did you multiply it by the 1.96 again?
Oh, I'm sorry?
You guys are breaking up.
Yeah, that's why I would be answering you guys, but I'm having trouble hearing you.
Okay, I did the 526 and then I just took it plus that margin of error, the 27.685.
Right. So we
Got 553.685.
That's what I got. Yes.
right, you do 526 plus the 1.96.
Well, we didn't calculate the whole thing.
We already did the 1.96 in the margin of error equation.
I didn't see this question. Oh, 1 point. I see.
So you just do
Oh, I see. Yeah, you do 520. Okay, I see. The 526 times the margin of error, right?
Okay, I see what you guys are saying. I got it.
Thanks, Allie. I forgot that we did that already.
And the sample size n is if n is increased. would
Okay.
increase. It would. Oh, okay. I got the answer for one of the
Are we
questions.
ready for number 9?
So again, what was the number you got for?
553.685.
What was 8 again?
553.685. And it looks like we lost Allie. There she is.
Sorry, my internet's being the biggest pain today.
Yeah, we've all been there.
Okay.
What is it?
Okay, so where are we at?
We're moving on to question 9, I think, now. What would happen
Okay.
to the width of the confidence interval if Gina increased the sample size?
If I just looked in the textbook for this, and I think if I understood it right, it would also increase.
Yes.
Right.
Yes.
Hang on. I put in my, when I did the homework, which I did the homework ahead of time because I'm gonna be gone all day today. I got that the sample size increases, or like as the sample size increases, the width decreases.
Smaller is the level of concentration.
No. Are you looking at question 10 on the homework? Because that's what I put initially too. But if you do go back and reread it, wait,
Yeah,
what are we
because
looking for?
Well, I was looking at question 16 about sample.
Yeah, as the sample size increases, the interval width decreases.
Okay.
so
Yeah, I was
Because
looking at
I only got first number 10.
Yeah, you're
would increase, and the fraction would decrease. Oh, I see it. Right.
Yeah.
Okay, because that's number 6 in the textbook on the online one.
Yeah. And then for number 10, it's talking about number 10 in the homework that you were talking about.
Yeah, it's 4.2 online. Anyway, I'm sorry.
Okay. So we're going to say it decreases then. But we're talking about the confidence interval. What would happen to the width of the confidence interval if
the increase
sample size?
The sample
And
size
then
is what's changing.
It's a sample size. So what would be 10 then? Would it increase?
Yes.
It decreases, but the confidence interval increases?
She's increasing the sample size, so the confidence interval.
Yeah, and in the video online, it says that as level of confidence increases, the width of the confidence interval increases. As the sample size increases, the width of the confidence interval decreases.
Right.
Okay.
So if you think level of confidence increase, width increase, sample size increase, width decrease.
It's just keep straight when it's the confidence interval they're talking about, or the samples, or the margin of error. So there's like 3 or 4 different relations that could potentially increase or decrease. So keeping straight is my problem right now.
Right.
All right. So 10 is what would happen to
Like straight wrote down note cards. I don't have them on me right now. I have them in my backpack somewhere, but I wrote note cards with all the formulas and with all these little statements because there's no way I'm gonna remember them if I don't.
Yeah.
Sample size and increase in the fraction would
If
be.
the confidence interval changes to 99%, which that's an increase because we were working with 95. So this is the one that I was talking about. Then it's going to increase as well. The width of the confidence interval will increase with the confidence interval increase. Oh dear. All right, are we good with
To be known.
all good to the end? Okay, Bright Bulb Light Bulb Company is planning a study average life expectancy of their light bulbs. They have known standard deviation, 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay, this is where we have to round it to a number.
Yeah.
And then the second trick is remember the heck you have all my paperwork.
So you take the 1.96 times
I got 246.
400 over 50. Is that correct, Ellie? You take the 1.96 times the 400 over the 50?
Yeah, and then you square it.
And then, and so it's 196, right?
1.96, yes.
Mm-hmm.
$245.8. So it's 246, yeah. So Allie, again, your answer is 246, is that correct? Because that's what I got.
No, random sample. Lower.
You see what?
Angie, are you there?
I'm here.
And then Allie looks frozen.
Yeah, and Tricia maybe can't hear us.
Yeah, I'm here. I'm sorry. I was just, I'm here. I'm just thinking.
Okay, good. I just want to make sure you were seeing how we came up with that number.
So again, you
No,
came up with 246, is that correct?
Mm-hmm.
Okay.
Yeah. Okay. Allie's signing out and signing back in, so hopefully she'll catch up with us. So let's look at the next part. We have three more, looks like. Okay, the mean salary of actuaries is 100,000 with a standard deviation of 36,730. And we want to know the mean salary for women actuaries. It's different than mean.
Yeah, so if you guys can help me with this one, that would be great. Sample size.
Oh, this is
All right, so the standard deviation, your interest to know if the mean salary, but we're not sure if it is.
We have a random sample of
What the
36, and we mean is what is the limit of this 95% confidence interval?
Right, so you're taking the X, which is the 111,000.
And we're going to go,
And you're going to multiply it, right?
The
By
lower limit.
zero.
No, you're going to minus the z-score. Oh, wait, what's the z-score?
Z-score.
we have a standard deviation of 36,730.
And the z-score. We put the 111 in the applet, and we find the z-score that way in the area.
No, there's the calculation. Okay.
I'm so confused.
I have everything but
Do
the
we just make
z-score.
the standard deviation divided by the population? Because that goes back. That goes back a little ways, a few lessons.
Wait a second.
Well, if I'm correct, the formula for that is the x bar plus or minus, in this case we're doing minus, z times the omega over square root of n.
So what are you doing, plus or minus what?
Or the standard deviation. Oh, so x bar plus or minus z, the z-score, multiplied by the standard deviation over n, the sample.
Just n or the square root of n?
Or the square root of
right?
n. No, the square root of n. Sorry. But, I mean, that's the formula. So do you put the, how do you get this? I have to remember how you get the z-score from, okay, so. Zero point zero five. What is that number? Oh yeah, that's right, because it's what percent? 95%, which is the 1.645, duh. Jeez. So it's 111,000 minus the 1.645 times 36,730 over the square root of 36.
Can you guys hear me now?
Yes.
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 Thank you. Okay. I got, for the lower limit for that one, I got 99,002.
Oops, what did I do wrong? So how did you calculate that, Allie? Let me see.
I found the margin of error first because that's just the easiest way for me to do it. But, and then I just did the 111,000 plus and minus that margin of error I found. But I have the other formula written down too. And I'm going to do it that way just to make sure that I'm not going to get a different answer.
Okay. 30 divided by the square root. 36.
Okay, so we're gonna let the phone your computer go. Okay.
Got
Yeah, I just did it both ways and I'm getting the same answer.
Okay, now just because the way you're doing it, Allie, let me confirm, because it does sound, so you took the 1.96 times the 36,730 divided by the square root of 36. Is that correct? Because that's how you get the...
Yeah. And 11 minus that.
Oh gosh, you're breaking up. Let's see.
Okay, so what's that?
I think she's not.
Okay, so
Can you hear me now?
yeah, so we don't even put the 100,000 in, right? We put the 100. Okay.
Oh, there you guys are.
Yes,
Can you hear me?
I can hear you.
I got
Yes, I can.
So I didn't ever
You
hear.
guys hear me now?
What was the final number you guys came up with on the lower limit?
I'm still trying to see if I'm getting this correct. So Angie, how did you calculate that? What was your answer?
I did what you're doing. I took the 1.960 times,
You guys hear me now?
you're echoing a lot.
Yeah.
So Teresa, I took that confidence interval, I multiplied it by the 36,730 divided by the square root of 36.
Okay.
And in the end, the number that I came up with was 99,001.53 for the lower limit.
Okay. I don't know why I'm struggling.
So, well, what number did you come up with for when you did that division? Did you get 612166?
Well, when I did 1.96 times the
Oh, yeah,
30
that's the wrong one. Yeah,
times the 36,730 divided by the square root of 36,
okay.
I got 11,999. So is that wrong?
I got 11,998.47.
But on that you have to round up, right? Or no? Or did I? No, you don't round up.
Yeah, not on this. Well, no, yeah, it says round to the nearest whole number.
But that's the final answer, though. Right?
No. Don't we have to subtract it? We have to plus or minus from the 111,000.
Right. So we have
Or
to.
does that number not
Yeah. So
bring
once
into
you,
this at all?
no, you do. You have to subtract it from the 111,000.
Okay. 19, that's what you got. Okay. I did here either then. I worked out mixed up. Okay.
Okay.
Yeah, so I got the 11,998.47, and that's
Yeah.
the number that we subtract from the 111,000 to get the lower limit, right?
Yeah. 9.
Okay. But we don't round it to the whole number at that point, not until we do the subtraction, right?
Right.
Okay.
Which I would
Okay,
say.
yeah.
Two, which is 990,002.
Yes, 99,002.
Mm-hmm.
Okay, 3 requirements. Okay, thank goodness, something easy.
And it's the last one.
All of the above.
Yes.
Okay. I don't know why this is always so draining. All right, I'm saving it all.
I'm sorry,
we'll see.
guys. I was trying to do the calculations with you. That's why I wasn't talking that much. So I'm sorry. I apologize.
No worries, no worries. Hey,
What
I'm
was-
submitting that.
For some reason, oh wait, what was number 13? I'm sorry. Was that the 99002?
Yeah.
900.
Oh wait, number 13 is 9902, and what was 12? Because I think I got the answers.
Yeah.
Okay, well, we got a 96.43.
For number 12.
No, that's what we got on the quiz.
Oh, okay. So
What
I think,
was-
was it 12, 13, and 14 that, or 12 and 13 that were,
12, 13, yeah, we got 0 points on 13, and I guess that's the only one. The rest of them we all, because that was only worth half a point, number 13.
well, 13, is going to be wrong because we have to add. We take the
Oh, because it was the,
11,000 plus 111,000 plus the 11,998 point.
Yeah. that's my fault. I'm sorry. I skipped over that one, essentially.
Yeah, so that's why I was,
Well, and you know what, though? I put for number 12, I put in, oh, no, that was right. Okay,
The-
never mind.
so
Yeah.
number 12, what did you put in?
Number 12, I put 99,001.53.
Wait. 99,
99,001.53. Because that one we're looking for the lower limit of the confidence level or confidence interval. And we were rounding that one to the nearest whole number. I didn't round it to the nearest whole number.
yes, my 12 was the 990,002.
Yeah. And that's what it should have been to me, because it says round to the nearest whole number, but it gave me credit.
And the
That
upper
was worth
limit. Plus.
I'm not going to go through and correct mine. I'm keeping 96.43 is still an A. I know what I did wrong. I get it. So, but for you guys, you can correct those and get 100%. I just don't understand why it's giving me a correct answer on number 12 when, but
Yeah, because number 13, you just do the opposite. You take that 111,000, and instead of subtracting, you add the 11,000.
yeah, exactly. So,
What did you guys get for? Okay, never mind.
Now, Angie, when you entered it, did you put the comma in or did you leave the comma out?
Okay, be right.
I think I left the comma out on my answers. It shows
Okay.
up in the answer.
Okay.
Yeah, I think when I actually typed it in, I didn't put a comma, but it shows up as a comma in the answer. So,
Okay. And then, I'm going to submit it and see. And I put the 990,000 too.
as a whole number.
Yeah, so I'm going to see what it tells me.
Yeah, just curiously.
Yeah. Okay, what did I get wrong? Oh, number 12 I got wrong, which you got right.
Yeah.
And again, will you tell me what you did put for 12 again? The numbers?
I have, well, actually, I don't know if this is the answer that I put or that they put. because I already submitted it, so I'm looking at the answers. These are my answers, right? That I have.
Right.
So I have 99,001.53. And it gave me credit for that. It's a half point, and I got 0.5 out of 0.5.
Yeah, that's interesting because it says round to the nearest whole number.
Yeah, exactly. So,
Sorry, guys.
well, we're just trying to figure out why they don't really want us to round to the nearest whole number on number 12, apparently.
Yeah, BYU Idaho seems. I noticed that with a different math class, like another math class I had to take, like the answers, some of their answers were wrong. But yet, when I took the quizzes and tests, like I found that I got the right answers, but when I put my right answer in, it was different, and I don't know, it's crazy.
Yeah.
I've been finding that a lot with the math classes here.
So,
Anyway,
either way, like I said, I'm done. I'm not going back and re-putting in all the answers for, 60.60% or whatever. I got an A, and I'm happy, and
Yeah.
I am going to be a little concerned about that, though, going forward when it says round to the nearest whole number.
Well, I think if we do it, so like in this case, because it said round to the whole number and we got it wrong, if it was the exam, that if you sign up to talk to the instructor afterwards, she'll give you credit for it. I know there were some of the answers on my exam, she gave me credit for them. Just like that bar, what was it, the bar or the box graph or whatever.
Yeah.
I put, I can't remember what it was, but I just put that that number there, but it was like 825 and I put 820.
Yes.
And so she gave me that credit.
Well, yeah, because that question was, it's like, okay, are we really, it's an estimation. So do we just go on that number or what? I put the 825 or whatever to begin with, but I didn't know. I was like, that's not a good question.
Yeah, I put 820 because it was too hard for me to see. Numbers. Yeah. So anyway, she gave it to me.
Okay.
So I think that if that happened on the test, as long as you're following the instructions, and if you got it wrong, then she'd probably give it to you.
Well, there we go. Another lesson.
All right. Thank you, guys. Thank you for your help.
Tricia, you're going to submit it on our little...
Yep, I'm going to do it right now.
Okay, thank you for doing that.
All right, thank you. Have a good day, ladies.
Who do we want to do it next time to start it? Should I try again?
You can try again if you like it.
All right, I'll give it a try next time, and if things go awry, then one of you please step in, and so have a great day, guys.
All right,
see you next time.
Bye.